So here we go. We are beginning section 6.4. It's simplifying radicals. And what is a radical? It's any type of root. We talk about square roots, cube roots, fourth roots. Those are all radicals. We've been dealing with square roots in the past. And these notes that we just handed out that you have right here, you've already seen them. We've already done them. We already know that taking the square root of a perfect square number is a nice perfect answer, right? The square root of 16 is 4, square root of 81 is 9, square root of 121 is 11. We know that. We want to take the square root of a perfect square number. And we also learned this fact in the past, that if you ever have two items that you're multiplying together in one square root, you could take that square root and split them to each of the items that you're multiplying. And we would use that skill or that fact to simplify a non-perfect square, the square root of a non-perfect square number. So if you did have the square root of 20, 20 is not a perfect square number. We want a perfect square number. So we use multiplication to rewrite 20 as 4 times 5. It would be totally pointless to rewrite 20 as 2 times 10 because 2 is not a perfect square and 10 is not a perfect square. Again, we want the square root of 4 in here. We want the square root of 16. We want the square root of 25. We want a perfect square number in here. And if you don't have it, rewrite it with multiplication to get a perfect square number. Then you could split the root to each of them and actually do the square root of that perfect square number to get a nice, beautiful answer. And this other square root of 5, it just comes down. This is a review. Technically, you should have done it in Algebra 1. We did it in Semester 1 of Algebra 2. I hope we all understand how to simplify square roots. Yay? Okay, let's move on to this part down here. Fact, a square root is the power of 1/2. This, for sure, we need to have memorized right now, okay? The square root is the power of 1/2. I don't know if you know this, but a square root technically has an invisible 2 right here. That's what makes it a square root. And if you don't see the 2, then you automatically assume that there's a 2 right there, okay? And you know what? Right here on the border of this page, right next to where it says fact, it might be a good idea to write down this. The third root is the same thing as parenthesis power of 1/3. And maybe this, the fourth root is the same thing as the power of what? 1/4. There you go. And it just goes on and on and on, right? You could say, you could say any root, whatever root you want. It could be 4, it could be 5, it could be 21. Whatever root you want is the same thing as saying parenthesis power of 1 over whatever root you had. Do you understand that? Cool. So the fifth root is the power, same thing as the power of 1/5. The eighth root is the power of 1/8, and so on and so on. Okay, so keep that in your mind forever, because you need that. Let's take a look at these guys down here. The square root of x to the 6th. Now, we just said the square root is really the power of what? Power of 1/2. The square root is really the power of 1/2. So that's what I'm going to do. I'm going to rewrite this guy. I'm going to rewrite that square root as parenthesis power of 1/2. What's on the inside? An x to the 6th. And we should remember from exponents, rules of exponents, that a power to a power, we multiply. What is 6 times half? 3. And that's our answer, x to the 3rd. Power to a power, multiply those powers. Okay. So one thing that I do want you to understand right now is if we do have a square root, which that's what this is, we want this power to be divisible by 2. Right? If I had a third root, I would want this power to be divisible by 3. You know what? Might as well, let's write that one down right here on the side. What if I had the third root instead of the square root of x to the 6th? Of x to the 6th. What's the answer then going to be? X squared. That's right. Okay, and if you wanted to show your work, you could rewrite your third root as the power of 1/3 with the x to the 6th right in there. And of course, a power to a power, you multiply. 6 times 1/3 is like dividing by 3, right? 1/3, multiplying by 1/3 is like dividing by 3. So you end up with x squared. And if you're like wait a minute, I'm not good at multiplying numbers with fractions. I mean, I could show you the process. 6 times 1/3. You would put the 6 over an invisible 1 and then just multiply the top with the top, the bottom with the bottom, and you'll get 6 over 3, which gives you 6 divided by 3, which is 2. I hope everybody knows that. Yeah? Okay. So let's just skip that one. These are too easy. The answer right there is 3 because the square root and the square undo themselves. What's the answer to this one? 2 to the what? Third. 2 to the third, because this is the power of 1/2, so you'd have 2 to the 6 to the 1/2 power, right? And power to a power you multiply, that's 6 divided by 2 is 3, so 2 to the third. Or you could actually do the answer 8. 2 to the third is 8. This one's a little bit more fun, okay? Now, we know that the square root is the power of 1/2. So we want this to be divisible by 2, right? Yeah. If it were a third root, we'd want it divisible by 3. If it were a fifth root, we'd want it divisible by 5. This is a square root. We want it divisible by 2, but it's not. So what would we do in the past, like with regular numbers? If I said the square root of 20, 20 is not a perfect square number. If you want a perfect square number, you rewrite it with multiplication to get a perfect square number. Right here, we want a power that's divisible by 2. We don't have that. We're going to rewrite it with multiplication to get a power that's divisible by 2. So I'm going to rewrite the x to the third. I'm going to rewrite that as x squared, because that's divisible by 2, times 1 more x. You guys all agree that x squared times x is x to the third, right? So all I did was rewrite this to look like this. And we know that the root is still there on both of them. And we know the rule that we could split the root to each of those. And of course, the final step here, you don't have to show your work at this point. If you know that this is square root, you want this to be divisible by 2. 2 divided by 2 is 1. So your answer is simply x, no more square root. And this guy, you can't do it, just bring it down, square root of x. So your answer is x squared of x. Just like if I were to ask you, what's the square root of 7? It's already simplified. You can't do anything to the square root of 7, so you would just leave it the square root of 7. Right here, square root of x, can't do anything with it, just leave it square root of x. Now, of course, we need to practice some more. Let's do that. Let's go down to this area, and let's just make some more problems. Let's say I had, I don't know, what kind of root do you guys want? Third, fourth, second root? What kind of root? Sixth root. The sixth root of x to the, give me any power. Well, any number. 24th. Okay, so the sixth root of x to the 24th. What's the answer going to be? Believe it or not, x to the 4th. We did it in our heads, right? And you guys just this one worked out a little too easy. I didn't want it to work out that easy, to be honest with you. But anyways, yeah, the sixth root is the 1/6 power. And of course, you have the x to the 24th in there. Bottom line is, sixth root, you want this to be divisible by 6. 24 divided by 6 is 4. So your answer is x to the 4th. Now, of course, if you would have rewritten it like this, a power to a power you multiply, 24 times 1/6, it's like 24 over 6, and then that gives you 4 anyway. So once you understand that if this is a sixth root, you want this to be divisible by 6, you could just get your answer without showing this work, okay? Let's do one that doesn't work out so nice. Let's try that again. What kind of root do you guys want? 6 again? And x to the 112. Okay, let's not get that crazy.
74.
How about less than 60? Anything less than 60?
52.
20. Why not 20?
20.
The sixth root of x to the 20th. Okay? So what do we want this to be divisible by? 6. Is it divisible by 6? No, it's not. So I want it to be divisible by 6, but it's not divisible by 6. So I'm going to rewrite it with multiplication to get a power that actually is divisible by 6. So what's divisible by 6 is pretty close to 20. It is 19. No, 18, right? 18. So I need to rewrite this. I need to rewrite x to the 20th, rewrite it as x to the 18th times x to the what? So I could stay true to the x to the 20th. X squared, right? You guys understand that, right? 18 and 2 is back to 20, right? Now that we've rewritten it with multiplication to get what we wanted, something that was divisible by 6, now we could split that 6th root to both of them and actually do this one, because 18 divided by 6 is 3. So my answer is x to the third. Now let's say like you're just like, what? How did you get x to the third? Show your work then. Write that 6th root as the power of 1/6. Write the x to the 18th right in there. And remember that a power to a power you multiply. 18 times 1/6 is 3. Okay? And what about this guy over here? You can't do that, could you? So you just drop it down. It's like saying, what's the square root of 7? You can't do it. It's still the square root of 7. Yeah, just drop it down. And the thought process is, could I divide 2 by 6? I can't. But you know what? This does bring up a special situation here. If I think 2 divided by 6, if I actually showed my work here, wow, we came up on a special problem here. The square root of 6, the 6th root is the power of 1/6, right? And x squared is in there. And a power to a power you multiply. Oh, this is a good one. 1/3. That's 2/6, which reduces down to 1/3, right? 2 times 1/6 is 2/6, which reduces down to 1/3. So what we really have here is x to the 1/3. But you probably want to write it in radical form because we started with radical form. So the x to the 1/3 is really the cube root of x. Aw, dang. Pretty cool, huh? Maybe that was a little too much for you guys right there.
Yeah, we should just...
No. Maybe that particular problem. Okay, let's go back to something basic. Check this out. This is really easy, but it's something that you need to know. What is the square root of -9?
3.
Nope. 3i. Right? You guys remember that? Yeah. 3i. Now, why is it not just 3? Why is there an I right there? Because what number times itself gives you -9? It doesn't work. 3 doesn't work. 3 times 3 is +9. And even -3 times -3 is also +9. There is no number multiplied with itself that'll give you -9. It just doesn't exist. That's why it's imaginary. Do we understand that?
Is that what I stands for?
I means that it's imaginary, that it's not real.
So whenever it's a negative, it's always going to be I?
Well, again, I don't want you to just memorize like, oh, if this is there, then this, like, I don't want you to memorize if this negative sign's inside there, then I have to have an I. Yes, that's true for square roots, but what I want you to do is really understand why the I is there. Because when you see a square root, it's asking what number times itself will give you -9, and there is no such number. That's why it's imaginary. That's why we have that rule that if you have a negative on the inside of a square root, it comes out as I. Then you have I square root of 9, which is I times 3, which is 3i. Okay? I want you to think about this before you answer. What is the cube root of -8? Think about it before you answer. What is the cube root of -8? Is it 2i? It's just -2. It's just -2. Believe it or not. Why is there not an I involved? Because what is this really saying? It's saying what number times itself 3 times will give you -8, and it's -2 times -2, that's +4, times another -2, that'll take you back to a -8. So right here, it really does, it works. You could actually do the cube root of a negative number. Okay? So I want to make this simple truth a fact in your mind. You cannot, you can't. You could do the square root of a negative, but you end up with imaginary. But you could actually do the cube root of a negative and get an actual negative answer. It's not imaginary. It's actually a real negative answer. Okay? And this is true for any even any even root. So like let's say I had the 4th root of -16. All right? The 4th root of -16. The negative on the inside is going to come out as an I, and then you're going to have the 4th root of 16, and then ask yourself, what number times itself 4 times? 2 times 2 is 4, times 2 is 8, times 2 is 16. So your answer will be I times 2. So right here it's 2i. Does that make sense? Anytime your root is even and you have a negative on the inside, yeah, for sure you're going to end up with an I. But when your root is odd and you have a negative on the inside, you could actually do that. So for example, if I said, what is the fifth root of negative 32? What number times itself 5 times will give you the answer negative 32? Negative 2. Okay? So that's a simple fact that I wanted you guys to know. Negatives inside square roots, fourth root, sixth root, as long as it's an even root, a negative in there is going to produce imaginary. But you could actually do the cube root, the fifth root, any odd root, you could actually do that odd root of a negative number and it'll give you a negative answer. All right, so we have a lot more to cover up here. This is all square root stuff. We actually have already done this in the past. Just a quick review. Once you get the hang of it, you don't even have to show any work like on this one. We know that a square root is really the power of 1/2. So we're going to split up that root to each of them. We have that right there. And the square root of 121 is 11. What's the square root of x to the 4th? Square root, that's really the power of 1/2. You want it to be divisible by 2. It is divisible by 2, x squared. Over here, square root, you want this to be divisible by 2. It is divisible by 2. What's your answer? Y to the 8th. And okay, let's say you're feeling rusty on this. Go ahead and rewrite the root as the power of 1/2 and show your work, all right? Y to the 16th right in there. Power to a power, multiply. What's 16 times half? It is 8 that you see right there. Okay, let's get to some more fun stuff down here. Here's a nice fact. Okay, this is nice, but not 100% essential for you to memorize. But I would memorize it because it's nice. What does this say? Anytime you have any type of root, whether it's a square root, third root, fifth root, seventh root, whatever, you could rewrite that root as a rational exponent. We already know that square root could be rewritten as a power of 1/2. We already know that a third root could be rewritten as a power of 1/3, a fifth root power of 1/5. But we're going to throw in an extra nice little fact here. Anytime you have a power inside or outside, and anytime you're dealing with the root, then you could rewrite it as the base with an exponent that's a fraction where you have the power, the power over the root as an exponent. I know that sounds really confusing. Just repeat after me. Power over root. Nobody repeated. Power over root. That's right. Power over, not check. What? Say it again. Power over root. Okay. So what base do I have here? I have the base x. What is my power? What is my root? 4. So what do we say right now? Power over root. So let's write the exponent as a fraction. Sorry, I put a highlighter instead. A fraction with the power 2 over the root 4. So what does that really mean? X to the 1/2. Because you could simplify 2 over 4. And not only that, since we started with the root, we probably want to end up with the root. So here's another fact. This is radical form. This is exponential form. And in the future, they will say, write your answer in exponential form, or they might say, write it in radical form. So let's say this is your answer, 100% correct. But you're looking at your multiple choice and it's not there. Maybe they have it written back as a radical, which means what radical is the power of 1/2? Square root, right? So this is what you're going to find as your answer. Again, power over root is a shortcut. Why do I say it's not 100% necessary for you to memorize it? Because let's go back to the original question 18, yeah? I could, if I wanted to, rewrite this fourth root right here. I could rewrite it as a power of 1/4 like I have been doing. And the x squared inside is still the x squared inside. And what do I do with the power with the power? You multiply them, right? And what is 2 times 1/4? It's 2/4, which reduces down to 1/2 anyway. So you don't have to memorize power over root. See you guys later. Good luck. You don't have to memorize power over root, but it makes it a lot faster, right? Let's take a look at this guy right here. If you know the shortcut, power over root, then you know your answer. What's your answer? X squared. Pretty amazing, huh? Now, let's say you forgot that shortcut, power over root. Well, you could always say, okay, what is the 4th root of x? I could rewrite that as the 1/4 power of x. And of course, I have the big 8 out here, right? And then you say a power to a power, multiply. Power to a power, multiply. What is 1/4 times 8? It's 2. So you get the same answer. But it's a lot faster to think power divided by root. That's your answer 2 as an exponent. Pretty cool, right? So again, if you want to memorize that shortcut, that's great. If you don't and you want to work it out, that's also 100% fine. What's that answer going to be? You guys want to use a shortcut? I do. You guys are thinking too much. I have the base, x plus 3, don't I? And now let's put power over root. What is the power? 8 over the root, 4. What's 8 divided by 4? 2. Answer is x plus 3. Well, that's the ugliest 3. Hold on a second. My goodness. That's the ugliest 3 I've ever drawn. X plus 3 squared. And that's it. Now, even if you didn't memorize that shortcut, you could have written the 4th root as the power of 1/4 and then 8 to the 1/4, a power to a power, multiply, you'd still get the 2 on the outside. How about that one? What should we do first? Split them up individually. That's great. And now we could go through each of these and just simplify them, right? What is the cube root of 8? 2. No more root, just 2. Okay, 2 times 2 times 2 is 8. How about the next one? I could use the shortcut, power over root, and get what answer? X squared. Okay, or if you didn't want to do that, you wanted to show your work, you could rewrite your 3rd root as the power of 1/3, and you could put your x to the 6 right in there, and then you can multiply power to a power, multiply 6 times 1/3 is the 2 that you have as an exponent. But you don't have to show that work if you get really comfortable with it and you understand power over root. Or you could even think of it this way. 3rd root, you want this to be divisible by 3. 6 divided by 3 is 2. Right? How about this guy? Could I do this? I can't, right? This is a 3rd root. I want this to be divisible by 3. I can't even rewrite it to get something divisible by 3. So this is as simple as it gets. I can't do anything with it. So I'm going to hold on to this and put it at the end of my answer. How about this guy? What does this equal? Z to the 3rd, right? This is the 3rd root. I want this divisible by 3. It is divisible by 3. If you went with the shortcut, power over root, 9 divided by 3 is 3. So Z to the 3rd is a part of my answer. That's on the outside. Let's not forget about the 2. That's the front part of our answer on the outside of the root. The only root that's left is this guy. We're just going to bring that down and write it at the end, the 3rd root of y squared. So there's my final answer there. We are not done. Oh, look at this. This one's just fun right here. It is. Okay, what do you guys know about the 4th root? What do you guys know about the 4th root? That's really the... Oh, man. The 4th root is? Power of 1/4. So what do we have on the inside? We have x squared. And what do we have on the outside? A big parenthesis and a big 6. Now these are all powers. Power to a power to a power. You're going to multiply all three powers. And when you're multiplying three numbers, it doesn't matter what order you do it in. You could say 2 times 1/4, which becomes 2/4, which becomes 1/2, and then multiply it by 6. That'll become 1/2 times 6, which is 3. So the answer is x to the third. Or you could have said, I want to multiply 2 times 6, that's 12, and then 12 times 1/4, that's still 3. Either way, your answer is x to the third. Now on the back side, we have a worksheet, and this worksheet is good practice. The answers are on Google Classroom. How about, what would this answer be right here? M plus 4. That's it. Because the 6th root and the power of 6, you want this number to be divisible by 6. It is. 6 divided by 6 is 1. M plus 4 to the 1 is unnecessary. You just write it as M plus 4. Now, let me tell you this on the answers provided on the book. For some reason, they put absolute values on the answer. Don't worry about those absolute values. Just ignore them, and M plus 4 is your answer. Okay? Now, there is an interesting question. Let's look at this last one right here. You see, we cannot split up a square root if there's addition or subtraction. It has to be pure multiplication. And we should recognize that on the inside, I really do have a quadratic trinomial equation. And that should trigger some memories of factoring quadratic trinomials, where you used to think, PTSD, where you used to think, what times what is your C value, that if you combine together is your B value. And you could plug it into this factored format. You should even recognize that 25 is a perfect square number, which means that what numbers belong in there with the x? 5 and 5. Now, that is still inside the square root. So all I've done is rewritten it, but it's still inside the square root. Now, I do have the option to split them, but even better, what I have here is a binomial times itself twice. So I'm going to write it as x plus 5 squared. That's a binomial times itself twice, with the square root on the outside of it. And now I should know that the square root and the square, what happens? Cancels out. Your answer is x plus 5. So like I said, this worksheet is practice. The answers are on Google Classroom. The worked out videos to every single question, I believe, is also on Google Classroom. So good luck. This is a good way to study.